Hello everyone, welcome back to Particulate Technology course. As you all know, this is one course that is being taught to third semester Diploma in Chemical Engineering students at SJ Government Polytechnic, Bangalore. So in the discussions held previously, we already have discussed one operation, that is size reduction operation, in the first unit. So in the second unit, we've been learning about the size separation operation. We already have finished the 4 sessions where we learned the various things that are related to size separation. We understood the size and shape of the particles, how to define the shape and size, and later on we learned about the methods of determining particle size in the given sample. Then we started discussion on the industrial screens. So first we learned about the screening operation, its objectives, and in the previous 2 sessions we have learned about the working and construction of two types of screens. One is a stationary screen, another one is revolving screen. So in the last session, we had a discussion about revolving screen, which are also called as trommels. Their construction and working principles were taught, and also we learned about various types of arrangements when more than one trommel is used for the given size separation operation. In today's class, we are taking up two important types of screens. One is the gyratory screen, other one is the shaking and vibratory screen. So as the name itself says, gyratory screen involves gyratory action or a gyratory motion, while this shaking and vibrating screen involve the shaking as well as vibrating action simultaneously. Let us discuss how these are constructed. First one we are taking up is a gyratory screen. So here the screens are gyrated either about a horizontal or a vertical axis. So when they are operated or gyrated about a horizontal axis, they are called as vertically gyrated screens, or they may be a horizontally gyrated screen if they are being gyrated about a vertical axis. So figure shows both the types of designs. The upper one is the vertically gyrated screen and the lower one is the horizontally gyrated screen. Coming to the vertically gyrated screen, just like other screening equipments, this also contains more than one DEX to separate out the given fraction into different sized given material into different sized fractions. The decks are arranged one above the other in such a way that the coarsest deck is at the top and the finest is at the bottom. Separate discharge ducts are provided for the material collected on each screen. So usually the casing in which both the screens are held one above the other are mounted such that they are inclined at an angle to the horizontal. Usually the angle of inclination will be between 16 to 30 degrees. The gyrations provided in a vertically gyrated screen will be about the horizontal axis, and these are produced by an eccentric shaft fixed to the floor of the casing exactly or almost at the center of the casing. It is in the midway between the feed location and the discharge. So that entire construction and the movement and operation is carried out to get the maximum amount of size separation done from a given type of screen. Here, the screens are usually rectangular in cross section, having a fairly long construction. So for any gyratory screen, the speed of gyration, the angle of inclination, and the amplitude of throw of the material over the screen during operation, all of these parameters can be varied according to our requirements. So in that way, these are much flexible kind of industrial screens compared to the one we discussed in the earlier sessions. So here in the figure, both the types of screens are shown. One is the top one is the vertically gyrated screen, the bottom one is the horizontally gyrated screen. So that is about the construction. The working of gyratory screen is much simpler. The mixture of particles which are to be separated into different fractions is taken on the topmost screen. Then the whole assembly is gyrated in the required direction. So due to which the sizing takes place and the material gets separated into different fractions by getting collected on different decks of the screen. Then through the respective discharge ducts, each fraction can be taken out as a product. The same kind of operation is seen in the horizontally gyrated screen also, but here the gyration direction is horizontal instead of being vertical. So that is how a gyratory screen works. Now let us understand the working principle of a shaking and vibrating screen. Figure shows a simple model, this simple sketch of a lab model of a vibrating screen. So as the name itself says, a vibrating screen is subjected to rapid vibrations with small amplitude to keep the material moving during the sizing operation. So this vibration also helps to prevent the binding of the screening surface. So binding is more likely to happen with the very fine material. So whenever you are supposed to separate the fine particles into different fractions, so what you are adopting is the vibrating action in a given screen to get the better kind of size reduction. The vibrating screen receives a vibrating action either by mechanical means or by electrical means. So according to that, we can call them as mechanically vibrated screen or electrically vibrated screen. The frequency of vibration is usually between 1800 to 3600. So even more number of vibrations can be provided per minute according to the requirement. So just like the gyratory screen, vibrating screen can also be arranged with a multi-deck fashion. That is, more than one deck can be used to construct a vibrating screen. So the different decks are arranged in such a way that the coarsest screen is at the top and the finest one is at the bottom. Figure shows the arrangement of three decks for the given vibrating screen. Here, each screen in the different decks are mounted with a slight inclination as shown in the figure. The inclination of the screen helps the movement of material over the surface of the screen. So this is all about the construction of a shaking and vibratory screen. So as I mentioned earlier, the shaking and the vibrating action to a screen can be either given by a mechanical means or an electrical means. The one which is shown in the figure is an electrically operated vibrating screen. The motor that is at the top of the screen supplies the vibrating motion to the screen directly. So that way we can construct the vibrating or shaking screen. So in case where the mechanical vibrations are provided to the screen, the vibrating actions are passed on to the screens from high speed eccentrics to the casing usually, and from the casings the vibrations are passed on to the screens. So whereas electrical vibrations are usually passed on from heavy duty solenoids directly to the screens so that only screens are vibrated. So that is a difference between electrically vibrating screens and the mechanically vibrating screens. Coming to the operation of a shaking screen. So in case where there are three decks, the material to be separated is put on the topmost deck. Simultaneously, the screens are vibrated either electrically or mechanically. The usual frequency of operation or vibrations is around 1000 to 3500 per minute. Due to this vibrating action, the particles in the equipment keep moving in the forward direction. So, by the inclination, the oversized material travels along the screen surface and is collected separately as seen in the topmost screen of the figure. Now, since there are three decks in the given vibrating screens, so we can obtain here four different fractions from the given material. So that is how we can use the vibrating screen. The oversized fraction is obtained from the topmost deck, and a slightly lesser sized fraction is obtained from the middle one, and a finer fraction is obtained from the deck of the lowest screen, and still small sized particles, the undersized particles, are dropped out from the equipment to the bottom where it is collected in a separate vessel. So that is how a shaking and vibrating screen can be used to carry out industrial screening operation. So that's all for today's class. Let me wind up with this slide. Thank you for being a part of the session. So before we end, let us just go back through a few MCQs. So which of the following has the maximum capacity? So whether it is Grizzly's, Trommel's, shaking screen or vibrating screen. See, even though Trommel's can be arranged for a very large scale operation, generally Grizzlies are the one which involve maximum amount of material being screened. So the answer for this question is the option A, that is Grizzlies. For the sizing of fine materials, the most suitable equipment is a vibrating screen because fine material are always have a tendency to block the openings in the given screen. So vibrating action is the most suitable action to prevent that binding of the screens. So the option is the last one, option D. In a vibrating screen, the screen is rapidly vibrated with a small amplitude. 2. For which of these purposes? Is it to keep the material moving and prevent binding? Or is it to increase the life of the screen? Or is it to save power? Or is it to prevent particle size reduction during screening? So the main objective of providing vibrations is to keep the material moving and prevent binding. So that is the main application of a vibrating screen. So the first option is the right option for the question. So which among the following screens are commonly used in industries where large capacity and high efficiency are desired? So very high efficient operation of screen separation is usually obtained by a vibrating action. So the option for this question is option C. So vibrating screens are the one that can be employed for a very large scale capacity or also to get a very high efficiency size separation operation. The casing in case of a gyratory screen is inclined at an angle between. So our right option for this question is 16 to 30 degrees. So let me thank you again for joining me for session number 5. Let's meet again back in the next session. Thank you.